Kia ora and welcome to this video on question 3 of the 2021 School Calc exam. There are 4 parts to this question. The first is a quadratic equation and we're needing to prove a trig identity to do with the roots. The second is a tangent question, which we're going to look at in 2 different ways. The third question is a fairly simple graphs problem where we're given the slope in the form of an angle. And then the last question is a perms and coms question, which I believe is covered in IGCSE, so Year 11 Cambridge. But for those of you who are at NCEA schools, you probably haven't seen questions like this, so we'll cover that in a little bit more detail. Okay, question 3, part A. So the first thing is, when we have a quadratic equation, such as this one, we need to realize that there's a relationship between the coefficients and the roots. So if I divide first up the whole thing through by a, I can factor that using the factor theorem, and in this case the question tells us the roots are sine theta and cos theta. If I expand that quadratic back out again, there are two terms that give x's. There's a sine theta x and a cos theta x, both with minuses. And then that last term, sine theta cos theta. The connection between the roots is the fact that the b over a term is always minus the sum of the roots. And the c over a term is always plus the product of the roots for a quadratic. Okay, so if we look at the question, it asks us to prove that some trig identity is equal to minus b over a. Minus b over a is equal to the sum of the roots. So our right hand side of that trig identity should come out as sine theta plus cos theta. Okay, so we've got 2 fractions, sine over 1 minus cotan, and cos over 1 minus tan. And I could put the fractions together straight away, but if you go a few lines through that, you end up getting cotans and tans coming up, and it sort of goes away from the original problem and away from where you're heading. So if we get rid of the cotans and tans first, so cotans cosine over sine, tan is sine over cosine. Then we put the fractions in the denominators together, and we can make 1 equal to sine over sine, and then we get sine theta minus cos theta all over sine. The other one, we can make the one cos theta over cos theta. So we get cos minus sine all over cos. Notice that my denominator fractions have smaller lines than the bigger fraction. Dividing 2 fractions times by the reciprocal, so I end up getting sine squared over sine minus cosine. Now for this other one, the denominator would be cos minus sine. If I want to switch it round to make it sine minus cosine, I'll just make this a minus. And the reason I've switched it round is so that I can make the denominators the same, and therefore I can put these fractions together. The top has now become a difference of 2 squares, so I can factor that. And the common factor, sine theta minus cos theta, cancels out, and we're left with our proof. Well, equals minus b over a, the sum of the roots. Okay, part B, we're going to look at it in 2 different ways. The first is way easier than the second, but You can actually use calculus to solve this problem. We're going to look first at the discriminant. So if we have, just bring up a Desmos graph first. I've already prepared this one. So you can see there that the hyperbola is in blue, the line is in green, and the answer is 10/3. That's where the line is tangent, or minus 10/3 on the other side. If you want to do that in your graphics calculator, you need to make y the subject of the hyperbola before you put in both equations. You can also do dynamic variables. So in this case, if I got rid of m and made it a slider, I can have a look at the values of m that are going to make that line tangent. You can do that on your graphics calculator. In the main menu, there's a button called dyna, which is standing for dynamic variable, but it takes ages. It even gives you a loading screen. But play around with that if you're interested. Okay, so if we take this equation of our straight line, y equals mx plus 2 root 21. It's always nice when they put the year of the exam in the problem. And we take our hyperbola, 16x squared minus 9y squared equals 144. Okay, if we dump the equation of the line into the hyperbola and just be very careful with algebra, we'll end up with a quadratic equation. Expand out the brackets. Mx times mx is m squared x squared. We've got two lots of the middle terms, mx times 2 root 21, 2m root 21, times 2 is 4, times minus 9 is minus 36. Minus 36 m root 21 times x. And then the last term, which is 2 root 21 all squared, so it's 4 times 21, which is 84, times 9. Turns out to be 756 minus 144 equals 0, and then put this into a standard form. And if the line is to just touch the hyperbola, the discriminant of this equation must be 0. There must be only one value of x locally where the line touches for a particular value of m. So discriminant b squared minus 4ac equals 0. And if we expand this stuff out, probably should have divided through by a number to make this a little bit nicer, because the numbers are going to become huge. We've got 27,216 m squared minus 32,400 m squared minus 4 times 16 times minus 900 plus 57,600. We have a negative m squared, but that goes on the other side. 5184 m squared equals 57,600. Divide by 5184, 100 over 9. So m is plus or minus 10/3, which is what my Desmos graph showed right at the start. Now, if you want to do this using calculus, it is a lot more tedious, but the first thing is we could say the line, this is an alternative method, a line, the gradient is equal to m for all points on the line, and for the hyperbola, we use implicit differentiation for the gradient function, and then we rearrange it, we get dy dx equals 32x over 18y, which simplifies a little bit to 16 over 9. and those gradients there are going to be the same at the point of intersection. So at the point of intersection, which we could call, I don't know, AB, we know that AB is on the line. Okay, so that must mean that B is equal to M times A plus 2 root 21. AB must satisfy the line equation. It also satisfies the hyperbola equation, which is 16a squared minus, actually hold up, 16x squared minus 9y squared. So 9 equals 144, and we know and M is equal to 16a over 9b. Okay, so I've swapped out the x and y's for a and b just because we're talking about a particular point now. But the particular point must be on the line, it must be on the hyperbola, and it will satisfy this gradient relationship. Okay, so if we, equation 1, equation 2, we substitute the m thing into equation 1. And times through by 9b. Alrighty. And then look at equation 2. If we rearrange this one, we've got negative 2 root 21 times 9b, 16a squared minus 9b squared, which equals 144 from equation 2. And then dividing, we get b is equal to 144 over 9 minus 18 root 21. And it comes out to be negative 1.7457 to 4 dp. Let's have a look at the Desmos graph. That is the y value of the point of intersection when the line is a tangent. So make it back to 10/3. There we go. And then to get the x value, we need to sub back into any of equation 1 or 2. I'll go equation 2 because it's a little bit easier to rearrange. We've got 144 plus 9b squared divided by 16 square rooted. If I sub that in, square it, times by 9, add 144, divide by 16 and square root. It's plus or minus 3.2733. That's the point of intersection. And then remember that m is equal to 16a over 9b. So if I times that by 16 and then divide by 9, lots of minus 1.7457. I get minus 3.3334. Now that should be minus 10/3, and the reason it's not is because I didn't work in exact form the whole way. If you want to prove it, leave that b in exact form, leave the a in exact form, and then put them into the formula there, and you'll be sweet as. It'll simplify to 10/3 or minus 10/3 depending on which value you've got, the positive or the negative. Discriminant way easier. Okay, part C, we have a cubic equation. Ax cubed minus bx, and we're told that a is positive. A and b are both positive. So that means, if we look at a cubic graph, it must be going up before it goes down, and then up again. We're told that this angle here is 45 degrees. That's at minus root 3, also 45 degrees at root 3, and it goes to the origin. Now if I substitute, actually I didn't need to know that it goes for the origin, because if I substitute x equals 0 into that equation, I get y is equal to 0. But if I sub the other point in, either of them, so when x is root 3, y is equal to 0, I get 0 equals a times root 3 cubed minus b times root 3. Root 3 cubed is root 3 times root 3 times root 3, 3 root 3. And then if I divide through by root 3, I get b is equal to 3a. So that's one of the relationships we need between b and a. And if I zoom in on the 45-degree thing, what that's telling us is that the slope at that point is equal to 1. The slope is rise over run, and for it to be 45 degrees, the tan of 45 is 1. Okay, so if I differentiate the equation, 3ax squared minus b, at x equals root 3 or negative root 3, the slope is equal to 1. So I get 1 equals 3a root 3 squared minus b, and that tells us that 9a minus b equals 1. Solve a simultaneous equation. You get a is 1/6 and b is equal to 1/2. And then the question asks us to find the slope, find the value of f dash 0, find the slope at the origin, which we know is a negative. Therefore, f dash of 0, looking at our gradient function, we sub in 0 into that, we get negative b. So negative 1/2 is the answer to the question. Not too bad, but we had to connect the slope of 1 to the angle of 45 degrees. Okay, last question is involving permutations and combinations. So I'm going to assume first up that you are an NCA student that hasn't seen much of this, if at all. It is in the curriculum, but often when we learn things we do the achievement standards and we don't see a place for the assessment of these things, so we might not have learnt them. Okay, so let's just start off with an example of, suppose you go to your favourite takeaway and there's a smorgasbord which has 5 food items. Okay, 5 food items, we'll call them A, B, C, D, and E. And suppose that you're going to choose 3. 5 food items, choosing 3. Okay, so first up, there are 5 different food items you could pick in the first go, because you could pick A, B, C, D, or E. And there's 4 ways of picking the second, there's 3 ways of picking the third, 2 ways of picking the fourth, and 1 way of picking the last. But we're not actually picking those ones. So 5 times 4 times 3 is the number of ways that we can pick 3 items out of 5. And let's just list them. So we could go and pick A, B, and C. Or we could pick A, B, and D. We could pick A, B, and E. Or we might not like the food, whatever A is offering us, so let's ignore A this time and just go B. We could go B, C, D, or B, C, E. C, A, B, C, A, B, D, A, B, E, B, C, D, B, C, E, C, D, E. Is that it? 3 and 6. Oh, no, what am I doing? You've got to list these down in a better order. So A, B, C, A, B, D, A, B, E is if you pick A, B first. or you might pick AC first and go ACD, ACE, really acing this problem. Or you might go ADE, or you might not pick A first, so you go BCD, BCE, or BDE, or C, CDE, and that's it. So how many have we got there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Brilliant. Now, you've got to decide, is this a problem where A, B, and C is a different dish to ACB, or BAC, or BCA, or CBA, or CAB? Because those are the 6 different ways of ordering 3 things. Okay, picking 3 things, 3, 2, and 1, 3 times 2 times 1, 3 factorial. So if those dishes are the same, if you're thinking about making a dish where the fried rice on top is different to the fried rice at the bottom, then you'd want to choose all of these as different combinations. Okay, so the first thing is a permutation, the 10 ways. And to get those permutations, we had 5 factorial, which was the number of ways of arranging 5 different things, 5 times 4 times 3 times 2 times 1, but we divided out the 2 factorial. That was me cancelling the last 2 because we were only choosing 3, and 5 factorial divided by 2 factorial gives you 5 times 4 times 3, which is 60. Okay, that's if all of the ABC, ACB, etc., etc. are all the same, because there are 10 ways of arranging, and then there are 6 orderings, so 10 times 6 is 60. A combination is if those different orderings, the order is not important. And I think of that because there's another N in combination. Order not important. In that case, we want to divide out by that 6, that 3 factorial. So we still have 5 factorial over 2 factorial, but we also divide out by 3 factorial, the number of ways of arranging 3 items, and that gives us 10. So that's a combination, and we call that 5C3, and we called the other one 5P3. These are on the graphics calculator. If you go into the option menu, hit OPTN, and then it goes probability, and you'll see that the buttons exist NPR and CPR. NPR is permutation. Oopsies, it's not CPR. What am I doing? I need CPR, all these mistakes I'm making. NCR is in choose R, or a combination. So if I type in for this particular one 5C3, I give it an answer of 10. And you might use that when you do a binomial expansion. If I had A plus B to the power of 5, the binomial coefficients are 1, 5, 10, 10, 5, 1. And there is 5 objects, and we're choosing how many A's are we choosing? 3 A's. There's A to the 5, 5A to the 4B, 10A cubed B squared. So 5 A's to choose from, we're only choosing 3 of them. How many ways can you do it? 10. Okay, so hopefully that little tutorial there's given you an appreciation of perms and coms, and enough to be able to solve this problem here. Okay, so how many ways can the 5 boys be ordered in the line? It's 5 slots. 5 people can go in this one. 4 people can then go in this one, and so on. So 5 factorial is the answer to that question. 120. 2 girls now join in, so there's now 7 positions in the line. We're treating the two girls as one entity because they're going to be standing next to each other. So if they're next to each other, there are two girls, and we're choosing two of them. And the order does matter because girl 1 then girl 2 is going to be different to girl 2 than girl 1. It will make the photo look different. So 2p2, and then the boys that are left, there's 5 boys in 5 slots, so we're choosing all 5, 5p5. If you multiply those two things together, 2p2 times 5p5 gives you 240. But then of course you have to consider the fact that those girls could be in anywhere of 6 different places. So we times that by 6 and we get 1,440. That's the answer to the question. And then the last part, 2 girls never stand next to each other. Well, there are 7 people. So there's 7 factorial ways of arranging them. And if we minus off the 1440, which is where the girls are standing next to each other, the remaining combinations will be the orderings where the girls aren't standing next to each other, 3,600. Okay, catch you in the next video.